This lesson is for section 9.3 on graphing ellipses. Our objective for today is to be able to graph an ellipse in the coordinate plane. So I probably should have mentioned this to you guys earlier in a previous lesson, but basically this entire chapter is the study of different conic sections. Now, a conic section is simply the intersection of a cone and a plane. So as you can see, we've already studied one such conic section. We've studied circles already. Now, if you intersect a cone on a diagonal, you can form what's called an ellipse. Now, some people think of an ellipse as a squashed circle. So that's kind of what we're going to be looking at, is a shape that looks similar to a circle, but it's not exactly a circle. In fact, a circle is a special kind of ellipse. Alright, so here's the formal definition for an ellipse. Now you'll probably want to pause the video here so that you can actually copy this definition down, but basically what it says is that it's the set of all points in a plane such that the sum of the distance from two fixed points, which we call foci, that distance will remain constant. Okay, so I think that definition is actually kind of tough to understand, so I found something online that I think does a nice job of helping you visualize what's going on and how an ellipse is defined. So the 2 points, F and G here, those are the foci that I was talking about. These are fixed points, meaning we can't move those. Now, point P is a point that lies on the ellipse. So remember how we define the ellipse. It's the set of all points, right? So here, if we drag this around, this represents all of the points on that ellipse. So here's the set of all points. Now, it was special. This point here is supposed to be a certain distance away from those two fixed points here, F and G. And what it says is that the sum of the distance between those points, so if we look at the distance here, that's FP and PG. If we add those together, we end up with a fixed distance. So here below, see how it has FP and then G here. So the segment FG, that entire segment length here, is constant. So FP plus PG is constant. Okay, now the general equation for an ellipse is pretty similar to a circle, but they are different, very different. So we start with x minus h squared, but then we divide this by something called rx squared. So this is r sub x squared. It's not two different variables, but this is a radius in the x direction. I'll define it a little bit later on. And then we're gonna add y minus k squared over the radius in the y direction, ry, r sub y here, squared, and that's always gonna equal 1. Now that might also be written as x minus h over r sub x, the whole quantity squared, because obviously if I square the numerator and the denominator, I'll get that same exact term here above. So then plus, similarly here, y minus k over r sub y squared. And that will, again, always equal 1. Now, in both of these cases here, in that general equation, h comma k represents the center of your ellipse. Now, the center of my ellipse in the diagram to the right here is at the point 4, negative 2, and I want to go through and kind of explain what this rx and r sub y is. Okay, so it kind of stinks. I can't actually show a full screenshot of the entire note sheet unless I really shrink it down a lot, and I don't want to do that. So I'm going to define these terms first, and then we'll actually go into the diagram to graph everything. So here the first term is r sub x, or sometimes I just refer to it as rx. This is the x radius. Okay, we're not used to having a different type of radius, but here we're calling this the x radius because this represents the distance from the center of the ellipse, so distance from the center to the actual ellipse, okay? But this is in a specific direction, this is in the x direction, so left to right. Now r sub y, or ry, is the y radius, and it's really similar how it's defined, but this is the distance instead from the center of your ellipse to the actual points on the ellipse here, but in the y direction. Now the points f sub 1 and f sub 2, or f1, f2, these represent the foci. Those are the fixed points that I was talking about earlier in that diagram. Now these are always going to be located on what we call the major axis, and I'll go through the vocabulary term here as well for the major axis. But on the major axis we find the vertices. Okay, so the vertices of your ellipse are always going to be located on the major axis. And the co vertices will always be located on the minor axis. And we'll talk about these terms here in relationship to the diagram. Okay, so let's come back to the diagram now so that we can draw in some of those parts. Now, as we mentioned earlier, the center of this ellipse is at 4, negative 2. Now, in this particular ellipse here, we see that we're elongated in the y direction. Okay, and you can see it visually because the length here going up and down, that's longer than the length going left to right. Okay, so we say that it's elongated in the y direction. Now, what we've formed here is something, this longer length here. This is called the major axis. Okay, we call it major because it's longer. And then here in blue we have the minor axis because it's a shorter length. Now Rx, remember, that's the distance between the center of the ellipse and the ellipse in the x direction. So this is the segment right here. This is Rx. All right, and we have two of those. We can label that as R sub x as well. So it's the radius in the x direction. All right. Now notice that it's exactly half the length of the minor axis. All right. So if you put two of the lengths of the Rx together, you get the minor axis length. Now, in this case, we have the major axis here. This is longer in the y direction, and we call this length here the radius in the y direction, r sub y. So again, r sub y is just the distance between the center and the ellipse, but in the y direction. So that length here is r sub y. Now, the endpoints of the major and minor axes, these are special points that we're going to label as the vertices and the co vertices. So the vertices are always the endpoints of the major axes. So these would be called the vertices, okay, right here. And we have co vertices. Co vertices are the endpoints of the minor axes. These are the co vertices here. All right, now we've got one more set of points that we have to discuss, and that's the foci. So remember, the foci are always going to be graphed on the major axis. So in this case, when we figure out where to graph those foci, they're going to have to go on this particular segment here on that major axis. Now, before we actually graph them, we have to figure out where they actually go. So what we're going to do is look at the equation for this particular ellipse. Okay, so you're probably going to want to fill all of this in below the graph here where you have some room. I'm just going to do this off to the side though. So here you can see I'm starting with the general equation for an ellipse. Now, based off of our graph, we can actually fill in all of the parts here to write the actual particular equation for this graph. So I notice I have a center at 4, -2. So if I fill in the top portion of each of those fractions here, I have x minus 4 squared plus y plus 2 squared. Okay. Now, this is supposed to be, each of these are fractions, okay, equal to 1. So let's work on the bottom part of that denominator here. Now, r sub x squared, this is just a length squared. So if I look at r sub x, I can just count boxes here. R sub x is 1, 2, 3, 4, 5 units long. So I'm going to square 5. And then for r sub y here, I'm going to square 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is x minus 4 squared over 25 plus y plus 2 squared over 81 equaling 1. So this is the equation of this particular ellipse. Okay, so we actually need this particular equation here so that we can figure out where we're supposed to graph our foci. So the location of your foci, first of all, it's supposed to always be on the major axis, but that location is actually determined by the r sub x and the r sub y. It's related to rx and ry. So I'm going to give you guys now that formula. Okay. All right, so here's the equation that's going to relate your focal distance. Okay, so here's the equation that relates your focal distance and your radius in the x and your radius in the y direction. So sometimes I even refer to this as the focal radius, but basically this represents a distance. It's not a point, so don't get it confused with F1 and F2 over here. Those represent the actual foci. Where you plot your points, you're going to write F1 and F2 to indicate that these are your foci. However, this capital F here stands for a focal distance. This is the distance between the center and the foci. So this is important. Make sure you are copying this information down. All right. So in our particular problem, to figure out where we graph those foci, we're going to start with this equation here. F squared is equal to the absolute value of rx squared minus ry squared. And then we substitute in the values that we already know. Above, we just said that rx was 5, so if we square that, we get 25. So I have the absolute value of 25 minus r sub y squared, that's 81. Okay. Now notice that we're taking the absolute value because sometimes the ellipse will be elongated in the x direction, and sometimes, like in our example above, it'll be elongated in the y direction, meaning this value could be larger than rx squared. So when we subtract here, we could get a negative value, but because it's a distance that we're looking for, we take the absolute value, and that also allows us to take the square root here of the right-hand side so we can solve for f, okay? If we got negative 56 and we tried to square root that, obviously it's imaginary, so we need it to be positive. So when I evaluate 25 minus 81 and I take the absolute value, I end up with 56. So to solve for f here, I must square root both sides, so I end up with f equaling root 56. So this is the focal distance, or the focal radius, okay? And again, it's the distance between the center and your foci. So if we come back now to the graph of our ellipse, we're ready to graph our foci because we know now the distance between the center of our ellipse and the foci. We know that that distance is the square root of 56. In other words, that distance is somewhere between 7 and 8 units long, okay, because the square root of 56 falls between the square root of 49 and the square root of 64. So that distance from the center to the foci is about 7 to 8 units long, okay? So that means I'm going to plot the point by going up 1, 2, 3, 4, 5, 6, 7, and then putting it between 7 and 8 units. So I'm going to call that F1. Now it doesn't matter if you call that F1 or F2, but this is a focal point. This is one of your foci, okay? Now I go down the same amount of units. So if I go down 1, 2, 3, 4, 5, 6, 7, and about between 7 and 8, here I'll plot point F sub 2. So make sure that you're always plotting these on the correct axes. So this has to go on the major axis because that's where we always put the foci, on the major axis. It always goes on the longer axis. So this is the graph of this particular equation. We're going to practice a couple more so you get comfortable with it, but it's not too bad once you understand the terminology. Okay, let's start with example 1. Now, for these problems, you want to make sure you include some important information every single time. This is something that you'll be assessed on as well. So we have to make sure we are practicing this in our notes and in our homework. We want to find the coordinates of the center. We also want to find the coordinates of the major and minor vertices, which remember we call the vertices and the co-vertices, as well as the foci. Okay, we're going to make sure we label each of these ordered pairs as well before we even graph our ellipse. Okay, so based off of this equation here, I see that my center would be at 0, 0. Okay. Now, because the fact that this value underneath the x squared term is larger, I know that this ellipse is elongated in the x direction. R sub x is 5, while R sub y is 3. So to find those values, you just square root each of these terms, okay? So right now, this is definitely an ellipse that's elongated in the x direction because this number is larger. Now, for the major vertices, which I'm not going to call major vertices, sorry, I'm going to call them just the vertices. For those vertices that fall on the major axis, that's kind of why they're called major vertices. But for those vertices, we know that we're going to translate our center 5 units to the right and 5 units to the left because that's R sub x. So before I even plot it, I know that the points are going to be negative 5, 0 and 5, 0. This is a skill that you'll need to be able to do very quickly. You don't want to plot points first and then try to figure out the vertices because when you start getting to writing equations of ellipses and other conic sections, it's very important that you can do some of this stuff in your head, okay? Now for the co-vertices, and those are called also above here, we call them the minor vertices, but we're going to call them just co-vertices. Now in this case, we're going to translate, again, this center, okay, 3 units up and 3 units down. So the co-vertices here should be at 0, 3 and 0, negative 3. In other words, I'm taking only the y value here and I'm moving it up 3 units and down 3 units. Now the last thing I need are the coordinates of my foci. So to find my foci, remember we solve this formula here. F squared is equal to the absolute value of R sub x squared minus R sub y squared. So if I solve here for F, I need to substitute in 25 and 9. So I have 25 minus 9. This is the R sub x squared and the R sub y squared. And we end up with F equaling 4. So after I get this value 16 and I square root, I end up with F equaling 4. That means that the foci are 4 units away, this time in the x direction, because that's representing the major axes here, because this is the larger number, so that's going to dictate where the major axis lies. But we want to be 4 units away to the right and to the left of my center. So my foci, the coordinates here are going to be at 4, 0 and negative 4, 0. So notice that we're able to find all of this information here before we even start to graph the ellipse. And that's kind of something I want you to be able to do. Like I said, it's going to be important when you start writing equations that you can do a lot of this work in your head. So let's start by plotting here the center. So we have a center at 0, 0. Make sure you are plotting and labeling your points. Now we have vertices at negative 5, 0. So it looks like right here. And 1, 2, 3, 4, 5, 5, 0 here. And that makes sense because if you look at r sub x, that's supposed to be 5 units long. Okay, so that distance here is 5 units long in both x directions. Now for the co-vertices, so these are the vertices here because they lie on the major axis. For the co-vertices, I'm going to go only up 3 units and down 3 units. So I have the point 0, 3 and 0, negative 3. So these are the co-vertices. So now I'm just going to do my best to include all these points with a nice round curve here to show the ellipse. And the last thing I want to do is plot my foci. So for the foci here, in this case, we don't have to, approximate anything because we're landing right on negative 4, 0 and right on 4, 0. And this time I'm just going to label this as f sub 1 and f sub 2. Now, off to the side, this is not something that's important for graphing this particular ellipse, but it's something that's going to lead us into tomorrow's lesson. Notice that the length of the major axis here, that's 10 units long. Okay, and the length of the minor axis is 6 units long. Okay, it's exactly double Rx and Ry. Okay, in example 2, now instead of having an equation, we have an inequality, but this is still in that same standard form for an ellipse, so I know that it's going to still be an ellipse because if I were to replace that sign with an equal sign, I now have the equation for an ellipse. So remember what we did when we graphed a circle. This indicates that we're going to have a boundary line. Some of the points will be shaded and some of the points will not be shaded, so we'll have to figure that out once we graph our ellipse. So for right now, we're just going to treat that as if it were just a normal equal sign. Okay, so the first thing we want to do here is identify our important information. We have a center at 3, negative 4. Our r sub x here is going to be 4 units long, and our r sub y is 7 units long. Again, I'm just taking the square root of each of those values. So because this value here is bigger, that means I know that the major axis lies in the vertical direction. So this is going to be the longer of the two axes. So it's elongated in the y direction. Now based off of this information here, we can now find the co-vertices and the vertices of this ellipse. So remember, the vertices will lie on the major axis, which means it's going to be dictated by this particular value here. So I'm going to write vertices next to r sub y, and I'll write co-vertices next to r sub x. Now if I want to find where these points lie without having to actually graph this particular ellipse first, I can find them by just thinking about where the center is. The center is at 3, negative 4, and the fact that the vertices have to lie above and below that center in order to lie on the major axis. Now because they lie above and below them, the x coordinate has to remain the exact same. Okay, the x value here has to be 3. Now we are moving 7 units up and 7 units down to find those vertices. So really all I have to do is add 7 to this number, negative 4, which gives me 3, and I have to subtract 7 from negative 4 to give me negative 11. So now I have the two coordinates here of those vertices without actually having to plot anything first. So the vertices are going to be at 3, 3, and 3, negative 11. Now I use that same strategy now for the co-vertices. For the co-vertices, I know that from this center, I'm going to move to the right, and I'm going to move to the left. Because I am moving left and right, the x changes, but the y does not change. So I know that the coordinate has negative 4 for the y value. So here, if I want to find the x value, we look at this r sub x. R sub x is 4, which means that from this center, I'm moving 4 units left and 4 units right. All I have to do then is subtract 4 and add 4 to 3. So to go left, I subtract 4, and I'm going to end up at negative 1, negative 4. If I add 4 to 3, I end up with 7, negative 4. So we have co-vertices now at negative 1, negative 4, and at 7, negative 4. So even though I drew a picture here to help you visualize, I'm hoping that you'll soon be able to do this in your head. When you start understanding how to translate these points up and down and left and right, you'll really have a good understanding of how to write equations of conic sections, which is the harder part. Graphing is pretty easy and straightforward. It's finding equations from given information that's a little bit tougher. That's our next lesson for tomorrow. So one of the things I want you to work on is try, when you're doing your homework, to do some of this translating here in your head, okay? Okay, so anyhow, let's go ahead and graph this information. The center of our ellipse is at 3, -4, so about right here. And since we have an ry that is larger than our rx, we know that's going to be elongated in the y direction, which places our vertices above that point at 3, 3. Okay, so here, and 3, -11, which is right here. All right. Oops, forgot to label this one. Our co vertices are going to be at -1, -4. And at 7, -4. So 1, 2, 3. There we go. All right, now let's draw in the ellipse here. But because we have this less than or equal to symbol, I have to make sure that I'm not drawing it in dashed. In this case, it is going to be solid because of the equal to here. But always make sure you're paying attention to the inequality. All right, it's a little detail you don't want to forget. All right, so there's my ellipse. Now, I want to make sure that we always label points, just in case you accidentally graph the wrong point. Make sure you're labeling it so that I know where you were trying to graph your point. The one thing that we haven't found yet is where to put our foci. So remember, to find the foci, we have to solve this formula here. F squared is equal to the absolute value of rx squared minus ry squared. So if we make our substitutions here, we have 4 squared, let's just write it in as 16. So 4 squared is 16 minus 7 squared, so 49. And to solve now for f, we will take the square root of this value here. Once I take the absolute value of this number, I get 33. So I have to take the square root of 33, and that's my focal radius. So f, that focal distance, is root 33. Now, this is the part when you have to list your foci that's really important, your understanding of how you translate your points. So I'm going to erase here real quick. All right, let's leave the center exactly where it's at. We know that the foci are supposed to be graphed on the major axis. In this case, the major axis is in the y direction. So I want to graph my foci above and below this center. So the only thing that will change about the coordinate 3, -4 is the y value. 3 here will stay the same for the point above and for the point below. The only thing that changes, like I said, is this -4. Now we're moving this up root 33 units, and we're moving it down square root 33 units as well. So when we talk about what happens to this y value, we take -4 and we add root 33, and then we take -4 and we subtract root 33. So these are the two coordinates for your foci. So if we write this in here, f sub 1 and f sub 2, and I'm just going to abbreviate this a little bit quicker. I'll write this as 3 and then -4 plus or minus root 33. Okay, please make sure that you realize these are two different coordinates. It's not one coordinate. Okay, so these are your two foci. So if we go ahead and graph these, I'm going to start at that center at 3, -4, and I'm going to translate it up root 33 units. Now root 33, that's between 5 and 6 units. So we're going to go 1, 2, 3, 4, 5, and then between 5 and 6 is about right here. So let's go down 1, 2, 3, 4, 5, and about 6 puts us about right here. So here's f sub 1 and f sub 2. Now, last but not least, we need to make sure we shade correctly here. So remember, to shade this, you always want to test your center because that's the fastest thing to test. So if I plug in the point 3, -4 into this particular inequality, the entire term here becomes 0, which means the whole term goes away. Same thing with the second term, so I have 0 is less than or equal to 1. Is this a true statement? Yes, it is true. Since it's true, we will shade on the inside of the circle where that center exists. I'm sorry, the inside of the ellipse. I hope I haven't said circle a bunch of times because I should be saying ellipse. All right, so that's the graph of this particular ellipse. Again, I just want to make a note real quick that the major axis here, okay, that's 14 units long. So the major axis, the length here, that's 14 units, while the minor axis, that length, is 8 units. So all I'm doing is doubling the Rx and the Ry to figure out the length of the major and the minor axis. Okay, that is the end of the lesson. So tomorrow you guys are going to get some practice with graphing, and then the following lesson we'll start writing equations for ellipses. Nice job. See you guys in class tomorrow.